Let us look at proposition number 23 of works of Archimedes. More specifically, book 1 of On the Sphere and Cylinder. The proposition says the surface of the sphere is greater than the surface described by the revolution of the polygon inscribed in the great circle about the diameter of the great circle. So here, great circle of a sphere basically means the circle with the same diameter as the diameter of the sphere. We can take any one diameter of the sphere and draw a circle with that diameter. That would be the great circle of the sphere. Okay, so let's proceed and see how we can prove this. Take a great circle ABC dot 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 on a sphere. Inscribe a regular polygon ABC dot 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 A prime dot 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 C prime B prime A, whose sides are multiples of 4. So we can have 8 sides, 12 sides, 16 sides, and so on. Let A prime and M prime be the diameters perpendicular to each other. Join opposite angular points of the polygon B prime, C prime, M prime, N prime, Y prime. Revolve the circle and the polygon about the diameter A prime. So keeping A prime as the axis of rotation, we revolve the circle and the polygon inscribed in it. Now here first I'll show you the rotation of this circle, and then I'll show you the polygon, because once I draw the circle and then if I draw or rotate the polygon will not be really visible. So let's take it one by one. So as you can see, it forms the sphere when we rotate the circle about the diameter A prime. Now let's remove this, and now I'll just show you the polygon being rotated. So if you observe carefully, then angular points of the polygon except A prime will describe circles on the sphere perpendicular to A prime. So this is one of the circles that is formed by the angular points D as it rotates around the axis A prime. Similarly, C, when it rotates, it forms this circle. This circle is formed. This circle is formed. And finally, this circle is formed. Now, the sides of the polygon will describe portions of conical surfaces. For example, let's take the BC is a side of the polygon. We extend it. Similarly, C prime, B prime, we extend it. And here they will intersect each other at a point at which this A prime A, when it is extended, will also meet. So for example, BC will describe a portion of the surface of a cone whose base is a circle of diameter C prime, and whose apex is the intersection of extended lines CB and C prime B prime, where A prime A would also meet. So let's form the cone and see how it would look like. Yes. So think about it like this. CB B prime, C prime. This is a frustum of that cone. Similarly, we have this cone. We would have another cone. Let me hide the previous cone. Here there is a cone. Here there is a cone. Actually, from M prime, we can have a cone on either side. Similarly, we will have a cone here and we will have a cone here. So let me make this disappear and now show you the cones again. You have a cone here, 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 and you have a cone here. Basically, portions of these cones are being formed by the rotation of this polygon about the A prime axis. So here, this frustum, you take any of these frustums and the segment of the circle, they would have the same extremities. So in this case, in case of C, B prime, C prime, you have a segment of the circle C prime, or rather C prime, and you have this set of segments of the polygon. They both have the same extremity. And what is that extremity? That is the circle formed by the rotation of C. And the polygon is inscribed in the segment of the circle. That means the polygon is less than the segment of the circle. And same thing would apply to all the other parts of the figure as well. So if we take the hemisphere M prime and the figure described by the revolution of the polygon, which is included in the hemisphere, have the same boundaries in one plane, and both are concave in the same direction. That is the circle M prime, which means that the surface of the hemisphere is greater than the surface formed by the inscribed polygon included in the hemisphere. And the same would apply to the other side of the sphere as well. So what we have shown is that the surface of the sphere is greater than the surface described by the revolution of the polygon inscribed in the great circle about the diameter of the great circle. That is proposition number 23 of works of Archimedes, specifically book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes each of these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.